In this video, we will explore a little bit more alternating current electricity. So I'll start with the AC power source as usual. Now this time, I will use a resistor. These lines here that you see, that's like it's a code based on color that communicates to us what is the specific value of the resistance for this resistor. And then I will use wires to connect the resistor to the AC power source. And as before, we see the electrons moving back and forth. Their motion is determined by the frequency. The period is determined by the frequency. So if I set the frequency of the AC power supply to a greater number, then I have a smaller period. Now, the difference between the bulb and the resistor is that here you don't see the effect of the brightness of the bulb fluctuating, changing over time, and that's why in the previous one I started with the bulb. Here with the resistor, we can measure the current, we can measure the potential difference, but we don't actually see, we don't have any visual effects from the alternating current. Now what I want to do is take essentially an ammeter, and we're going to plot the current that goes through the resistor as a function of time. And as before, let's see, I'll change the frequency a little bit. All right. And now observe here, as we did before with the bulb, the current that flows through the resistor fluctuates in a sinusoidal way as a function of time. Okay. Now let's do, I'll bring the voltmeter here, and let's start by placing the two electrodes here. Now notice, so if I remember that the potential, the way that the voltmeter works, essentially it is telling us the potential difference V red minus V black. Okay, so it's telling us what the potential here is with respect to that point. And if I do the other way, essentially what I'm doing is I'm including a minus sign in the potential difference compared to the previous one. So the two measurements, whether you have it, the black one is here and the red is there, or the red is there and the black is there, those two numbers are off by a minus sign. Now I'm going to keep it this way because I want to show you something. Compare how the graph of the current and the graph of the potential difference fluctuates over time, and in particular see how they are going up and down. They're going up at the same time and they're going down at the same time. They reach the maximum at the same moment and the minimum at the same moment, and they're both zero at the same moment in time. Okay, when you have an ACR circuit, and the R stands for the resistor, the current and the potential difference are in phase. Okay, there is no phase difference between the two. As I said, that's because, let's see, I'll pause it. Because they reach the minimum at the same moment in time, their maximum takes place at the same moment in time, and the zeros take place at the same moment in time. So the current and the potential difference in an ACR circuit are in phase. And I'm emphasizing this because this is not always true in other circuits where we have capacitors, inductors, or capacitors and inductors. These two quantities may not be in phase, and we're going to see that. But as far as an ACR circuit is concerned, those two quantities are in phase.